What's up, Honors Chemistry? We're going to be doing a midterm review specifically on the topic of Lewis structures. This video will basically encompass four examples that are here, some of which you can find in your midterm review packet. So if you have already attempted some of these that are in your midterm review packet and you are still stumped, this video will hopefully help you out in explaining how to draw these structures. All right, and here, if you look here, this is a list of 7 steps that I made. And if you follow it, you should be able to draw out your Lewis structures. So please, if you do have time, take a look at these 7 steps. We'll be referencing these 7 steps as we draw out our examples, but just take a look at it if you do have time. All right, so let's go on to our first example, carbon tetrachloride. So our first step really, when it comes to drawing Lewis structures, is we want to count out the number of valence electrons we'll have in our Lewis structure, so that at the end we can count out how many electrons we have in our Lewis structure, and we can verify whether or not we drew it out correctly with our calculation. So what that essentially means is we'll look at carbon and see how many valence electrons carbon has, and we'll look at chlorine and see how many valence electron chlorine has, and we'll multiply that by 4 because we have 4 chlorines. So first of all, how do we identify how many valence electrons an element has? Well, I think the easiest way to do it is we can just look at the periodic table, and we can draw a quick electron configuration and see how many electrons are in our highest energy level. So if we look at carbon here, we see that it's a 1s2, a 2s2, and a 2p2. All right, so if I'm to write that out, a electron configuration, it's carbon is 1s2, 2s2, and 2p2. All right, and this is for carbon. So valence electrons, as hopefully to remind you, is the number of electrons you have in your outermost energy level. We know that in carbon, our outermost energy level is our second energy level. And we know that there are 2 electrons in the s subshell and there are 2 electrons in the p subshell. So we know that total in the second energy level, the outermost energy level in carbon, there's a total of 4 valence electrons. So carbon we'll consider to have 4 valence electrons. And we'll add that to chlorine's valence electrons. But keep in mind we have 4 chlorines, so we have to multiply whatever number of valence electrons chlorine has to 4. So now we can look at chlorine. Chlorine, if you drew out its electron configuration, is 1s2, 2s2, and I believe it is 2p5, I believe. Yes, it's 2p5. Because it is a halogen, so it can only have 5 in its p subshell. So we see here that the second energy level is the outermost energy level for chlorine, in which it has 2 electrons in its s sublevel, 5 electrons in its p sublevel, so a total of 7 valence electrons. So 7, we'll draw out a 7 here, electrons. And now we'll add this total number. So we have 4 plus 28, which is 32 electrons. So we know that when we draw out our Lewis structure, we should have 32 electrons representing or shown in our Lewis structure. So the second thing we have to do is we have to find our central atom. Our central atom will always be the atom that is least electronegative. And the reason, and many people say, oh, it's easier to just memorize it by understanding that it's the first element that shows in your compound. And that's kind of misleading, because if you look at a molecule like water, its formula is H2O. But hydrogen is not its central atom. Oxygen is. And the reason that oxygen is its central atom is because hydrogen is an exception. So that's why I highlighted it here. Hydrogen will never be your central atom. So the best way to memorize it is to look at the periodic table and see which one is least electronegative, as we mentioned before. We see that in carbon tetrachloride, we see that carbon is all the way here and chlorine is here. And we know that on the periodic table, the most electronegative element is fluorine. So obviously, if chlorine is pretty close to fluorine, we can make the assumption that chlorine has a pretty high electronegativity compared to carbon, which is further away from fluorine. So carbon will be our central atom because our central atom will always be the element that is of least electronegativity. So we'll draw our carbon right in the center. And now we have to draw out the number of valence electrons that carbon has. So 1, 2, 3, 4. It has 4 valence electrons, as we already discussed, as we already calculated it with its electron configuration. And simply all we did was we drew it in the center and we drew out the 4 valence electrons. Now what we can see here is that carbon needs to complete its octet, meaning that each of these lonely electrons needs to be paired with another electron. So we can have 2, 4, 6, 8. So we have to distribute these 4 chlorines in a way in which these 4 electrons will be shared with one of chlorine's electrons. So what I'm going to do is I'm going to distribute chlorine. 1, 2, 3, 4. And now what I'm going to do is I'm going to draw all the electrons, all the valence electrons that chlorine has. So 1, 2, 3, 4, 5, 6, 7. And before you guys say, oh, well, why didn't you add an electron here? Well, the reason I didn't add an electron here is because I want these 2 electrons to be shared with each other. And I can't I can't share electrons if I already have 2 here. So what I'm going to do is I'm going to leave this spot with 1 electron and leave this spot with 1 electron so that they can share with each other. Same principle applies here. 1, 2, 3, 4, 5, 6. Oh, I'm sorry. I made the same mistake. Let me redraw that. Okay. 1, 2, 3, 4, 5, 6, 7. And I want to leave this lonely. I want to keep this lonely so that this electron and this electron can share with each other. Same thing applies here. I'll quickly draw out the remaining electrons. These 2 can share with each other. 1, 2, 3, 4, 5, 6, and then a 7th one here. So now what I'm going to do is I want to share these 2 electrons, so I'll make a bond with them. So I shared these electrons. So carbon technically has 2 electrons because it's sharing one of chlorine's electrons, and chlorine technically has 2 electrons here because it's sharing one of carbon's electrons. So now we have to check, do all of these complete the octet? So carbon has 2, 4, 6, 8. It's an octet. And chlorine has 2, 4, 6, 8. It's an octet. Check for all of them, and all of them do have an octet. All chlorines have an octet, and all carbons have an octet. So we know that, all of these atoms are going to be happy. Now we have to do our final step, which is checking over our work, which is taking this number, these 32 electrons, and see if we represented all of those electrons in our electron structure, in our Lewis structure, and make sure that we didn't let go of any of them. So what we're going to do is we're going to count out all our electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We have 32 electrons represented in this structure, and we calculated that we would only have 32 electrons in this structure, so we know that we drew this correctly.